What's up, everybody? Today, I think is going to be really fun. I put a lot of effort into it, so at least I hope it's really fun. And if it's not, then that's fine too. Then I learned something that sometimes the amount of effort I put into something doesn't mean how fun it's going to be, but whatever. Um, Thought it'd be nicer to like start these videos off with actually like seeing me, rather than just seeing like some sort of slideshow, because you get enough of the slideshow, may as well see some Murray time. Um, yeah, let's move on to the main show of the day. So today is going to be themed around a my favorite anime, themed around Death Note. If you haven't seen Death Note yet, it's on Netflix, and you should watch the first episode after this. It's a little bit scary, so and I do mean just a little bit. Like it's more of a drama slash thriller. So let that be your choice. But if you have seen it, then you're probably going to like the second half of today quite a bit. Um, okay, got a little do now just to warm us up though. We've got an atom on the right hand side of the screen. We're asking a couple of questions here. What is the mass of this atom? What is the net charge of this atom? And here's a true or false. I can make this atom unstable by changing the number of electrons it has. True or false to that one? You will answer that on your sheet for today. It's going to be titled Week 2, Day 2. I don't know, something. I'm going to change the name a little bit right here. But here you go. Here's the do now. Take a second, pause, and do that. All right, answer coming at you live. Mass of this atom. Mass, only protons and neutrons in the center have mass. Electrons have no mass. So protons, 1, 2, 3. Ooh, that's got 3. Neutrons, 4, 5, 6. In total, it's 6, because there's 3 protons plus 3 neutrons. The mass of this is 6. What is the net charge of this atom? Okay, for every proton, that gives me plus 1. So plus 1, plus 1, plus 1, that gets me at a plus 3. Electrons subtract 1. Because I'm at plus 3, now I subtract 1. I'm at plus 2, subtract another 1. Ooh, this ends at plus 1. The net charge is positive. That makes sense because there's more protons than electrons. If we have more protons than electrons, it's a positive charge. True or false? I can make this atom unstable by changing the number of electrons. Electrons do not change stability at all. Electrons have nothing to do with stability. They only change charge. Only the combination of protons and neutrons can change this from stable to unstable. All right. Last class. This is a quick review of what I just said. Protons and neutrons have a mass of 1. Electrons have a mass of 0. That's why the protons and neutrons were drawn really big, and the electrons were drawn really small. Stability. Only some atoms are stable. You can make them unstable by changing the number of neutrons or protons. The combinations of which, generally speaking, if you have an equal number of protons and neutrons, that is likely a stable combination, but it might not be. That's why you have this simulation to check it. See this one right here? Lithium is stable because it got 3 protons, 3 neutrons. That's a stable combination. Another stable combination of this is with 4 neutrons and 3 protons. Those are 2 different stable. Charge. Protons give you +1, electrons give you -1, neutrons give you 0. Reminder that this net charge button, very helpful for that. Look, we got 3 protons right here, the 3 pluses right here, 2 electrons right here, 2 minuses. If we add more protons, then we get more pluses. It becomes more positively net charged. If we add more electrons, ooh, then it gets more negatively charged. It went from +1 to 0. Now it's in the negative range. Now it's further in the negative range. Note another way, if you can, it's not just like adding things, you can also subtract things. So right now we're at neutral charge. If I wanted to become positive, I can take away an electron. I don't just have to add a proton. I can just take away electrons and it becomes more positive. The simulation shows that really perfectly. This class, there's going to be a little choice review or new simulation. Then there's no Kahoot for the online version of this. There's a break, which is also not for the online version of this if you're watching this video. And then there's the final assessment, which is going to be dope. I tried really hard. So the review is not going to be on this video. If you want to review, I highly recommend playing around with this simulation, and checking the grade that I left on your most recent assignment. And say to yourself, like, do I need more practice with this simulation? If you do, then there's a game. Oh, snap, I went to the wrong thing. There's a game. Give me 1 sec, it's gonna reload. The game here, if you want to practice, don't do that. I'm sorry, folks. Well, if you're watching the YouTube video, you can skip past the part where I'm fumbling around with this anyways. Go to the game, get out of that game, and go to this one. This is the game that you want to do. Let me do that again. Only this game right here. This game, not helpful. This game, not helpful. This game, not helpful. The one in the middle right here. You want to do this. So mass numbers, ask me protons, neutrons, electrons. I would add these two together. Protons, neutrons get 18. I would type in 18. I would do check. It would give me the right answer. That's what you want to do for review. Otherwise, you are going to follow along again with this worksheet that I'm going to rename. And you're going to take 10 minutes and get as far in this as you possibly can. If you don't get all the way to the bottom, don't worry about it. But you're going to take 10 minutes to get as far as you possibly can on this worksheet. It's very straightforward. It tells you exactly what to do. It's going to bring you to this screen where you can click around on this screen. This thing is called the periodic table of elements. It's going to be like our bread and butter. It's going to be the holy grail of chemistry. If you notice that your computer is lagging, don't click the ones down here. The ones at the bottom, although really cool and interesting, might make your computer freeze. Try and stick up here when you're trying to investigate some stuff. Yeah, notice that like if I say like click on something, I mean like you have to like find the square and you got to click on it to like make it change. Notice that each time I click these, the name changes and the number changes. Yep, take some time to do that. And now I'm going to start reviewing the final assessment. Okay. So this final assessment, oh boy, oh boy. If you're watching this, you're either reviewing the instructions in class or you are doing this solo. So for those of you who have not seen Death Note, you might not get any of these references, but for those of you who have seen it, you're going to love them. And those of you who haven't seen it, I'm sure you're going to like it anyways. Okay. For Death Note nerds, all of these slides are going to be titled after episode names that I think are pretty applicable here. So I'm going to read this along with you. So you're taking a post-pandemic stroll, and one day you come upon this strange notebook called the Chem Note. As soon as you, let me go full screen here. It's probably better. As soon as you touch the Chem Note, a horrible demonic creature appears before your eyes. They are the Murigami. There's a blank look in their eyes. The Murigami, Gigi, tells you that this is no ordinary notebook. This Chem Note gives the owner, which is you, the power to transform any atom into any other atom. There are, of course, a few rules. Here are our rules that we want to follow along with today. And as a note for some people who might be confused right now, these are the rules you have to follow in order to pass the learning goals. But if you're following along with the story here, these are the rules you have to follow to make this Chem Note transform any atom that you want to transform. So you're going to have to start with atoms, with one atom that you name. That atom has to have a mass greater than 5. It has to be unstable. The one that you start with has to be unstable, and it has to have a positive net charge. That is going to be on page 8 of the Chem Note, or if you're following along, it's going to be slide 8. You know, I'm trying to make this work here, folks. And then on page 9, you're going to list every single change that you have to make to this first atom in order for it to become the new atom on page 10 of your Chem Note. In the end, your atom must have changed name. You cannot have the atom with the same name. In the end, it started as unstable. It must end as a stable atom. It started as a positive net charge. It has to end with a neutral net charge. So on page 9, if you're going to make changes to your atom that you start with to make it turn into this atom, you have to list all of the changes that you make. So This is going a little bit further into it. This is level 4 territory. The Murigami eyes. If the owner of the Chem note wants to wield the full power, they must perform a ritual to obtain the Murigami eyes. The Murigami eyes allow the owner to see exactly which atoms make up the objects they look at. So that means you could look at anything in the world and tell exactly which atoms are inside of it. In order to unlock these eyes, you need to unlock them through the ritual. You must do every one of the rules that's on page 5, which is this page. All of these rules must be followed. In addition to that, you must follow an extra set of rules here. This is why this is the level 4. You've got an extra set of rules. Your transformation from the first atom into the second atom must be done by adding or subtracting 1, 2, 3 of the subatomic particles. And what do I mean by that? I mean you could add 1 proton, 2 neutrons, 3 electrons, while also following page 5 rules. Or you could add 1 electron, 2 protons, 3 neutrons. Or you could think of any other combination that goes 1 of one kind, 2 of a different kind, and 3 of a third kind. Note, there's so many combinations you could do to this, and there's tons of answers that can work for this. I didn't even calculate how many total answers can possibly work for this, but it does require some work. It does require you to be creative. You can also subtract the SAPs as well. So you could say, oh, I'm going to add 1 electron, subtract 2 protons, and add 3 neutrons. As long as you're following the 1, 2, 3 rule, I'm okay with it. And if you want me to check it, shoot me a message. Okay. It seems that the Murigami accidentally left you some helpful writings inside of the Chem note. Use these to your advantage. So, if you want to enter the Murigami realm is our... The Murigami realm will bring you back to this. This Murigami realm is obviously very helpful for you. All of the tools and features are available to you in the Murigami realm to make your sets of atoms. Okay, so when I'm referring to, on this slide, page 8, 9, and 10, those are slides 8, 9, and 10. Notice how I've made some stuff for you here. I've already outlined a lot of stuff for you already. So you see that you've got your orbitals in place already. You need to replace the name, and you've got some subatomic particles up here already. What I want you to do is not drag these. Do not drag these. Do not do that. What you will do is you will click it. You will do Command copy or Control C, and then Control V. Notice how it made a second one in place. And you're going to do that in order to add your subatomic particles. So if I want to add, say, gray neutrons now, I will do it this way. I will not drag these. Keep these here. If you drag these, you're going to have a bad time. Everything has to be in the right place. And I trust that you will be able to do that if you're following along. You want to list your mass and your charge you start with and whether or not it's stable or unstable. This one should be a given, considering it's one of the rules. The mass is also one of the rules. The charge is also one of the rules. So do not choose just random masses, charges, and stability. Those are rules. Even if you're not following the level 4 rules, even if you're following the level 3 rules, you need to have particular ones here. Here, you're going to list all the changes that you make in order to get to your final atom. You might be asking me, Murray, how do I know what my final atom is? It can be any other atom, as long as you do these 3 things. As long as you make it change name, as long as it ends stable, and as long as it has neutral charge, neutral net charge. That means you can subtract subatomic particles if you want. If you subtract subatomic particles, I want you to say, the first change I made was, I subtracted X number of these subatomic particles, or I added X number of these subatomic particles, where like X is obviously the number that you actually did it with. I don't want you to write the word X. That clearly doesn't mean anything to me. The Murigami, obviously, me. The Murigami is like interested in you as a human. They come all the way from the Murigami realm, and you start to wield this powerful chem note. And I just really want to know, what do all these humans think about the power of the chem note? Why is it powerful? What would you do to make the chem note more powerful? Murigami needs to know. How could you use the chem note to do good? How could you use the chem note to do evil? What would you use the Murigami eyes to see inside of? And you can answer this question even if you didn't do the level 4 rules. Totally fine with that. Hope this is fun. This is going to be due Saturday, but you should have enough time in class to finish it. So if you're watching this to restate the instructions, you definitely need to finish this inside of class. But I will obviously allow some extra time. That's it from me. I'll do a little stop share screen. A little bye-bye. Toodaloo. Enjoy your evening. Evening? I guess it's my evening because it's 11:30 when I'm recording this. What's up? All right. Later, folks.